This video is on mole-to-mole calculations. In order to do them, and all of these calculations in Chapter 9, quick review is knowing how to just convert everything to moles. So if you remember that moles are in the middle and everything converts to them, so there are some conversion factors to know. There are videos reviewing this in Chapter 3 if you feel like you want to go back and watch them. So whenever you're converting moles and mass, you always need to use the molar mass as your conversion. So that's on your periodic table. So that number, it's red on your periodic table, that's the number of grams per mole. When you're converting moles and particles can be molecules, atoms, or formula units and other things, you use Avogadro's number, 6.02 times 10 to the 23rd. There's that many particles in 1 mole of everything. In converting moles and volume, it's 22.4 liters. Now remember, this is only for a gas at what we call STP, which is standard temperature and pressure. We'll talk later about when it's not standard temperature and pressure. So for now, everything is at STP for our assumptions. So we'll be using these, like I said, throughout the chapter. So let's just talk about first just mole-to-mole calculations. So the relationship between elements and compounds. In a chemical reaction are the coefficients. Fix this. So we learned how to determine these last chapter when we were balancing. So now let's talk about what those mean. They are a relationship, and we can use those as conversion factors. So let me go through this reaction as an example. Okay, so first we should balance this. So we got to put in our coefficients. So nitrogen, I have 2 on the reactant side, so to get 2 on the product side for the ammonia, I'm going to put in 2 as a coefficient. So my nitrogen is now balanced. Hydrogen, I have 6 on the product side, because 2 times 3 is 6, so I need to multiply the hydrogen on the reactant side by 3. So there's my balanced reaction. Now, in front of this nitrogen, there is a number. It's just not written. It's not 0. It's 1. Normally we don't write 1s. I'm writing it just for this example to demonstrate this. So these numbers show this relationship between every element and compound in our reaction. So for instance, what this means is, let's say I'm going to compare nitrogen and ammonia. The numbers are 1 and 2. That means for every 1 mole of nitrogen, there are 2 moles of NH3. Okay, so let's say I have, in my reaction, I start off with 5 moles of nitrogen. Okay, and the question is, how many moles of NH3 will I have? Well, my ratio is 1 to 2. That means my ammonia is always going to be twice as many moles as my nitrogen. So if I have 5 nitrogens, I'm going to have twice as many ammonias, which would be 10 moles. Okay, that's what this relationship shows us. That's what the coefficients tell us. So another example, let's say we had 12 moles of ammonia. How many moles of nitrogen would we have? Well, ammonia is twice as much, 12. Half of that would be 6. Okay, so let's use this in a problem, and I'm going to show you how we write it out. So you're going to always have to have a balanced reaction for all of these problems. So we're going to use the same reaction up there for my example. So it says, how many moles of nitrogen will react with 2.45 moles of hydrogen? So what I normally do is I write down underneath each thing in the problem what I have and what I want to know. So 2.45 moles of hydrogen. I'm going to rewrite my equation. N2 plus 3H2 makes 2NH3. Okay? So I have 2.45 moles of hydrogen. So 2.45 moles. Okay? And the question's asking how many moles of nitrogen will react with that. So I want to know this. Okay? So basically I'm taking my question, and I don't want it to be in like a word problem anymore. I want it to be more simply, what do I know, what do I not know? My knowns and unknowns in my reaction. So converting moles to moles, I'm just going to look at these coefficients. So it's 1 for my ratio, or sorry, 3 to 1. So you start by writing your knowns, so 2.45 moles. You write your number, you write your unit, and we have to write what it is. It's H2. Okay, so conversion factors, those coefficients, that's what we're going to put on the top and bottom of the line. To know which one goes where is just like before when we did conversions. When you want something to cancel, you put it opposite. So if I want to get rid of moles of H2, I'm going to put it on the bottom. So it will divide out. So I want to get rid of moles of H2 and I want to find moles of N2. So units first, then figure out your numbers. Your numbers are these coefficients, this 1 and this 3. So 3 for H2, 1 for N2. Okay? Look what I get to cancel. Moles of H2. The units go together. That's 1 unit, moles of hydrogen. Cancels because it's on the top and the bottom. So now I'm going to take my calculator and do 2.45 divided by 3. Right? I don't need to multiply by 1. That won't change anything. So 2.45 divided by 3 gives me 0.816 repeating. Well, I have 3 sig digs here. So my answer is going to have 3 sig digs. So 0.817 and let's make that a little neater. Units. Well, whatever doesn't cancel. So moles of N2. So there's my answer, and that's how to convert from moles of one thing to moles of something else in a problem.